Okay, good morning, grade 10s. Today we're going to be looking at simplifying exponential expressions. We're going to go through 4 different examples in total. But what I'm going to do is I'm going to separate the videos into 4 different parts for this section. So, there are basically 2 main types of exponential expressions that you need to know or be aware of. The first type is what we call the multiplication and division type. Those, in my opinion, are the easier ones. And then we also have the addition and subtraction types. Okay. Just to note, in most cases, we are trying to make all the bases the same. These bases should be different prime numbers. So always try to not factorize them out, but factorize them out, split them up into different prime numbers. So like the number 6 can become a 2 times a 3, or the number 9 can become a 3 squared. We're always trying to break them down into prime numbers so that we can work with them, okay? In most cases, the variables in the exponent cancel out, okay? That means that we are normally ending up with a final answer that doesn't have any variable x or y or n or m, so no variables. So if you do get a final answer that has a variable in it, you might have done something wrong. And again, you might have to split some of those numbers up. So just be aware of that, okay? Just to quickly go over some important exponential laws that you need to know for this section, I've highlighted the important ones over here for you. So the first one is the multiplication law, right? If we have a to the power of m times a to the power of n, notice that the bases have to be the same for this law to apply. Okay, if we multiply those together, we add our exponents. Okay, I'm just going to quickly go to the division one over here. If we divide two exponents with the same base, we subtract the exponents. Then we have anything to the power of a negative exponent is basically the inverse of that, okay? We want our exponents to typically be positive and not negative. So if we have a negative exponent, what we do is we just inverse it. And then last but not least, we have a power to a power. And in that case, we have to multiply exponents. Now I've added the reverse over here because they are very important, okay? This is splitting over here. If we have 2 exponents that are being added to each other, we can split them up, multiplying them together with that same base that they started with in such a way that we see it over here. And then again, the inverse, I've written it the exact same way over here, I see. But the inverse, what you'll often have to do is when you have 1 over a base to an exponent, we can often just flip that around and it becomes to the power of negative n in this case, a to the power of negative n. Okay. If you aren't familiar with those or you struggle with those, just go and revise some of those examples from your textbook or from your schoolwork. Just revise that before continuing. All right, so we're going to start off with the multiplication and division type, okay, for this first video. And I always say to my students, you know, it is important to identify the type of problem you are trying to find a solution for before even beginning. Just look at the question, try to identify which topic this falls into, because that's going to help you start the question. The scariest thing is when you don't know where to start, okay? So let's quickly look at how we identify the multiplication and division type, okay? So here we're given an expression, okay? Expressions do not have equal signs in them. This is an expression. We have 3 to the power of x plus 1 multiplied by 3 to the power of x divided by 9 to the power of x minus 2. Okay, firstly, we can see that there is a variable on the exponent. Okay, that tells me that we're dealing with exponents, okay? We're dealing with exponents, all right? We often want to solve for x, so we want to completely simplify and get rid of the x often, okay? So there's a variable in the exponent. I also identified that there's multiplication and division, okay? This is one massive single term. Yes, I know there are multiple terms up in the exponent over there, but this is one single term because there's no plus or minus living in between here, okay? This is multiplication and division only. Okay, so we're dealing with the multiplication and division type of exponents. Okay, and just as a side note, identify that I'm dealing with a 9. I know that 9 can become 3 to the power of 2. So here are some useful tips that are going to help you solve these types of problems. First of all, we are going to make the bases the same. That is very important. Okay, we're only going to have our bases in terms of prime numbers. Okay, we're going to use our multiplication and division laws to add or subtract the exponents in order to simplify our expression, and the variable usually completely disappears. So if you end up with an answer where you still have an x in as an exponent, you might have done something wrong, so just be aware of that. Okay, let's go through the first example. So the example 1 says, basically simplify the following expressions. Okay, again, I identify that this is the multiplication and division type. All right, there is a multiplication. This dot over here means multiplication, so we have a multiplication sign there. My exponent is a variable. And now I know that what I want to do, first things first, I want to try and make all the bases the same. Okay, so what do I have over here? I see I have a 3, and a 9. Now I know that my 9 can become 3 squared. Okay, if you're unfamiliar with how to if you're unfamiliar with all of your numbers, just write them on the side. Obviously 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27, and you can do these for all of the numbers. You know, you have 2 to the power of 1, which is 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is going to be 32. These are all extremely useful to know, guys. So please try to familiarize yourselves with those, okay? So 9 is going to become 3 to the power of 2, okay? And that's x minus 2. Now what I need to do is I need to use my exponent law to multiply this into my bracket. Okay, that x minus 2 is going to multiply into that squared over there. So I end up with 3x plus 1 multiplied by 3 to the power of x, all divided by 3. Now think about this on the side here. That's 2 multiplied by x minus 2. Okay, using my distributive law, we know that this 2 is going to come in and affect both of those. Okay, so what I get is going to be 2x minus 4. So that's 3 to the power of 2x minus 4. Now that all my bases are the same, I can use my exponent law, my multiplication and division law, okay, to start off by writing that base 3 over there, and wherever they are multiplied by each other, I'm going to add the exponents, and wherever they are divided by each other, I'm going to subtract the exponents, okay? So what does that look like? So what I recommend if you are just starting out with this, or you are prone to making silly errors, which we all are, I recommend just writing these in brackets. That's x plus 1, okay? That's this one over here, plus an x, right? That x is by itself, but we can just put it in brackets anyway. And then it's going to be minus 2x minus 4. This is where most of you make mistakes. That's minus 2x minus 4. And you guys make mistakes because you forget that this negative actually comes in and changes the sign of both of those terms inside of the brackets there. Okay, so put them in brackets and then add and subtract them so that you avoid making silly errors. what does that become? That becomes 3x plus 1 plus x minus 2x plus 4. Okay? Now we're going to look for our like terms. We have an x, and a negative 2x. Notice how those are all going to cancel out. Okay, this is usually always the case. All right, my other like terms are going to be a negative 1 and a positive 4. Okay, so what I end up with is 3 to the power of, all these x's are going to cancel. That's a single x, and a negative 2x. So that is 3 to the power of 5. Okay, and you can use your calculator to go and get that correct answer. I'm not going to do that out of my head now, but there you have it, 3 to the power of 5. Okay, let's have a look at another one. Usually what happens is you guys will see a fraction and you'll completely freak out, okay? Fractions are not as scary as they appear, I promise. This half is really a 2 to the power of negative 1. Okay, remember we have an exponential law that says that if it's the reverse actually. If we have the inverse of a number, we can basically make its exponent, take it up to the numerator, flip it around, okay? So this is 2 to the power of negative 1 over 1. Basically what I've done is I've just flipped these around, but then I've made the exponent negative, okay? So I've inversed it. All right, so we're going to change that half into 2 to the power of negative 1. Let's see what else we have here. Here we have a 4. I know that 4 is equal to 2 squared. I have an 8. 8 is equal to 2 to the power of 3. And I have a 32. And I know that 32 is equal to 2 to the power of 5. So I can make everything, okay, have the base 2. That is the idea. We need to make the bases the same. Okay? So, what do we end up with? We have 2 to the power of negative 1 multiplied by 2 to the power of 2, and I recommend just putting that in brackets first and then keeping this exponent over here, 2x minus 1 multiplied by 8 becomes 2 to the power of 3, and I'm going to keep this 2x plus 1, and 32 becomes 2 to the power of 5, and that's to the power of 2x. We're going to do this step by step so that we don't make any errors, okay? What's going to happen over here is this 2x plus 1 needs to be multiplied with this 2 over here, and it's going to come and it's going to affect both of those. Check this out. 2 multiplied by 2x minus 1. This 2 is going to come in and multiply with both of those terms. We end up with 4x minus 2. What often happens is you guys work too quickly and then you get 4x minus 1. You guys do that all the time. Okay, be very, very careful of making silly errors like that. Take it step by step so that you do not make any errors, please. So this expression then becomes 2 to the power of negative 1 multiplied by 2 to the power of 4x minus 2 multiplied by 2 to the power of 6x plus 3. Okay, this becomes 2 to the power of 10x. Okay, and now that all my bases are the same, okay, I'm going to pop that base over here, and I'm going to take all of these exponents. I'm going to add the ones in blue, and I'm going to subtract the one in green. So what I end up with is negative 1, and I can put it in brackets, plus 4x minus 2 plus 6x plus 3 minus 10x. Okay, and I like to put it in brackets because what's happening is sometimes the sign will multiply in, and if we have multiple terms, that sign is going to affect all of those terms over there. Okay, next step, I get 2 So basically it's just negative 1 plus 4x minus 2 plus 6x plus 3 minus 10x. I'm going to quickly look for my like terms. I have a 1, a negative 2, and a 3. I have a 4x, a 6x, and a negative 10x. And notice how all the x's are now going to cancel out. So 4x plus 6x is 10x, which cancels with the negative 10x. Okay, and then I have this negative 1 and a negative 2, which is negative 3, plus a positive 3, which gives me 0. So I have 2 to the power of 0, and anything to the power of 0 is equal to 1. All right, beautiful. Let's have a look at the next one. So this is a good example of an exponent that has a base that you have to split. Okay, you're going to have to split that now. So what I'm identifying when I start this is that I'm dealing with a base 3 and a base 2. So we've got two different types of bases involved. I see that I have this number 6 over here, and this number 6 can be split into 2 multiplied by 3. Okay? So I can rewrite this expression in terms of 2's and 3's as my prime numbers. So I get 2 multiplied by 3. I'm going to put that in brackets. I always like to put whatever I'm manipulating, I'm just going to keep it in brackets, and then I'll multiply anything else in that I need to afterwards. That is to the power of n plus 1. At the bottom, I'm still left with 3n minus 1 multiplied by 2n plus 3. Okay, now I am looking at this n plus 1 over here, and this n plus 1, according to our exponential laws, is going to multiply into both the 2 and the 3. Okay, it's going to multiply and affect both the 2 and the 3. So how does that look? That looks like this. It is 2n plus 1 multiplied by 3n plus 1. Divided by 3n minus 1 multiplied by 2n plus 3. Okay, and now I have two types of bases. I have my 2's and I have my 3's. Okay, so we're going to have two bases now. I'm going to start off with the 2's. Okay, at the top over here I have this n plus 1 minus this n plus 3. So n plus 1 minus n plus 3 multiplied by, now my 3's, I have a 3, and this 3 has an n plus 1 minus an n minus 1. So that is n plus 1 minus n minus 1. And now what I can do is I can drop my brackets, and when I drop my brackets, these are obviously going to fall away. This negative comes in and affects both of these. And you guys often just leave this as a positive 3 and you lose a mark, okay? Remember that these negative signs come in and change the sign of each term inside of that bracket, okay? Very, very common mistake. Arguably one of the most common mistakes. So this ends up being n plus 1 minus n minus 3 multiplied by 3n plus 1 minus n plus 1. Okay, and now we can simplify one step further. Just going to quickly look for my like terms. I have n's over here and I have constants over here. Notice how my n's typically always cancel out, the positive and the negative n's. And what am I left with? I'm left with 2 to the power of negative 2 multiplied by 3 to the power of 2. Okay, we aren't done here yet. I am identifying that I have a negative exponent. Okay, and 2 to the power of negative 2, okay, is going to become 1 over 2 squared, which is the same as 1 over 4. Okay, I'm going to take this negative exponent and I'm going to bring it down and inverse it into the denominator. So what I get, just to be super thorough, I have 3 squared. I'm not doing anything with the 3 squared. It's staying at the top. I'm bringing the 2 to the power of negative 2 down underneath. So I have 3 squared over 2 squared. And we know that 3 squared is equal to 9 and 2 squared is equal to 4. So our final answer is 9 over 4. Okay. Next question. I see that I have a fraction with an exponent that has our variable inside of it. I'm looking at this 18 over here and thinking that I'm probably going to have to split that. I'm also dealing with a 2, okay? So from very simple observation, I see that my prime numbers that I'm definitely going to be dealing with is a 2 and a 3. But I'm going to quickly figure out what this 18 can become, okay? So this 18 over here can become 2 times 9. But 2 times 9 can also become 2 times 3 squared. So by doing that, I'm getting all of my bases in terms of prime numbers, and the 2 prime numbers that I am dealing with for this question is going to be 2 and 3. All right. Another thing that I quickly noticed is this is the third, and another way to write a third is 3 to the power of negative 1. Okay. So my expression now becomes, and I'm just going to work step by step, 3 to the power of negative 1, right, to the power of 2x plus 1 multiplied by my 18, I just said, becomes 2 multiplied by 3 squared. That's all to the power of x. Then I have 2 to the power of x minus 1 living at the bottom there. Okay, let's multiply in. Now this 2x plus 1 is going to completely multiply with this negative 1. Okay, that's the first thing. This x is going to not only multiply with this 2, but it's, the squared, but it's also going to multiply with the 2 over there. And this 2 to the power of x minus 1 is going to remain the same. So what does that look like? Have a look at this. This is negative 1 multiplied by 2x plus 1. Okay, that negative 1 is going to multiply into both of those. So my answer for this will become negative 2x minus 1. So this is now 3 to the power of negative 2x minus 1 multiplied by 2x multiplied by 3 to the power of 2x. Okay, remember that x came in and multiplied with both of those. And then I have my 2 to the power of x minus 1. Now I'm going to look for my bases. So I see these 3's, and I see there's some 2's over here. So I'm just going to start off with the 2's. That is 2 to the power of x minus, be very careful, this is an x minus 1. I'm minusing that whole x minus 1. Okay, multiplied by 3 to the power of negative 2x minus 1 plus 2x. Okay, because I took this 2x minus 1 and adding it to that 2x. Okay, let's have a look at what happens next. What I'm going to do is I'm going to bring this negative sign in, and it's going to affect both of those. Again, notice how step by step I'm just working through this as not to make any errors. 3, negative 2x minus 1 plus 2x. Now that I have everything in a nice neat row, let's have a look at what we can cancel. As we are used to, the variables typically cancel out. And what I'm left with is 2 to the power of 1 multiplied by 3 to the power of negative 1. Okay, I'm going to bring this 3 to the power of negative 1 down into the denominator. So I end up with 2 over 3. Okay, moving on to the next question, and it is our second last question. Getting more complex now, and in my opinion a little bit more fun. We see that we have a very mixed fraction over here, okay, not really a mixed fraction, just an improper fraction. We've got 4 over 27 to the power of x plus 1. Okay, you guys will probably look at that and be petrified, but don't worry, we're going to deal with that together. I see I have a 9. I see I also have a 3 and a 4 at the bottom there. Okay, immediately what I'm looking at is, okay, I've got a 4 that can become 2 squared, right? We've got a 27. I know that can become 3 to the power of 3, 3 cubed. I have a 9. I know that's 3 squared. I have this 3 over here, which can remain the same. And I have this 4 over here, which can become 2 squared. So I can technically manipulate this expression in such a way that I have all of my bases in terms of 2 different prime numbers, being the number 2 and the number 3. So let's just start with that, okay? Because those simple manipulations might be already scoring you marks. Okay, so we get 2 squared divided by 3 to the power of 3. That is x plus 1 multiplied by 3 squared, 2x plus 1. Then I have 3x multiplied by 2 to the power of 2, x plus 2. So I've changed all my bases to be in terms of 2's and 3's, okay? What's next? Well, this 3 cubed is still in the denominator. What I want to do is I want to bring it up to the top and I want to inverse it. It's going to become 3 to the power of negative 3. So let's start with that. And notice how step by step I am very simply working through this. I'm not jumping the gun. I do not want to make any errors. We're going to get this right the first time. So before I multiply these in, I just want to get everything onto the same level. That's 3 to the power of x multiplied by 2 squared x plus 2. Okay. Now what I can do is I can multiply my exponents in, but be very careful. According to our exponential law, that is going to multiply into both the 2 squared and the 3 to the power of negative 1. In a similar fashion, we have x, so we have 2x plus 1 as an exponent. That is going to multiply in with this 2. And then last but not least, we have this x plus 2, which is going to multiply in with that 2. But be very careful, just as an example, this one is going to become 2 to the power, 2 multiplied by 2x plus 1. Again, another very silly mistake that you guys make is you'll write this as 4x plus 1. You'll write that as 4x plus 1, forgetting that this 2 actually multiplies in with that 1 as well. So in actual fact, it is 4x plus 2. Okay, be very careful. No need to rush this. Okay? So what do we end up with? We end up with 2 to the power of 2x plus 2. Okay? This 2 is multiplying with the x and the 1. Okay? That is then multiplied by 3 to the power of negative 3x minus 3, multiplied by 3 to the power of 4x plus 2, divided by 3x, multiplied by 2 to the power of 2x plus 4. Okay? And now that I have it all written out, I have all my brackets multiplied in. Okay, what we're going to do is we are going to look for which bases are the same. So I have a 2 over here, 2 over here. So I'm going to subtract those exponents from each other. I also see that I have a 3, and a 3. So I'm going to add these two together and subtract that 1. All right. So that is going to come out to be, I'm going to start with my 2. That is 2x plus 2. And I can put it in brackets if it makes you feel better. Minus, in brackets now, I'm going to bracket this, 2x plus 4 multiplied by 3 to the power of negative 3x minus 3 plus 4x plus 2 minus x. Okay, and now we can simplify by dropping our brackets. Wherever you see a negative, we're going to change the symbols inside, so this and this is all going to become negative. I'm going to very simply, step by step, drop my brackets. So that's 2x plus 2 minus 2x minus 4 multiplied by 3, negative 3x minus 3 plus 4x plus 2 minus x. Now let's have a look for some of our like terms. This 2x and this negative 2x cancel out with each other. Over here we have a negative x and negative 3x, that's negative 4x plus a 4x all cancel out with each other. Notice how our variables have now dropped. This 2 and this negative 4 are going to end me with negative 2, and this 2 and this negative 3 are going to end me with a negative 1. So I have 2 to the power of negative 2 multiplied by 3 to the power of negative 1. And because both of these have negative exponents, I'm going to bring them underground. So I end up with 1 over 2 squared multiplied by 3. That's just a 3 to the power of 1. Okay? And that's the same as saying 1 divided by 4 times 3, which is 12. So 1 over 12. There you have it. Okay. And last but not least, we have one more question. These ones involve the 5s. Remember, there are some other prime numbers that we also like to test you on, like the 7s, 11s, but we don't normally go up over that. So this one involves the 5s. Okay, I see we have a 5. I have a 5 over there. So 1 over 5 is just going to become 5 to the power of negative 1. 25 is just 5 squared. And 125 is just 5 to the power of 3. Okay? So let us begin. That is 5 to the power of x minus 2. I'm not going to do anything there. I don't have to change that. Okay? This is now multiplied by 5 to the power of negative 1. 1 over 5 is the same as 5 to the power of negative 1. Okay? There we go. And that's to the power of negative 1. Then we have 25, which is 5 squared to the power of negative x, multiplied by 125 is 5 to the power of 3, and we have an x minus 1. Okay, so now I have everything strictly in terms of my base 5, and what I need to do next is I need to multiply these exponents into the brackets. Be careful of this one. Remember, this one is 3 multiplied by x minus 1, and that's going to become 3x minus 3. Okay? So, let's see what we end up with. We have 5 to the power of x minus 2 multiplied by 5 to the negative 1 to the power of negative 1. A negative 1 times a negative 1 is just going to give me a 1. So that's just multiplied by 5. And you can put it to the power of 1 if you want. This one's going to become 5 to the power of negative 2x. And this one's going to become 5 to the power of 3x minus 3. Okay. Now that I have multiplied all my brackets out, I am going to add these two together and then subtract these two. All with the same base, 5. So I have 5. Okay, in brackets I have my I have my x minus 2 plus 1 minus negative 2x minus 3x minus 3. Okay, notice how both of these in the denominators are minused from each other, and these in the denominators are added to each other. Okay, so what am I left with? 5, I'm going to drop the brackets now very slowly. X minus 2 plus 1 plus 2x minus 3x plus 3. Okay, looking for my like terms, I have an x and a 2x, that's 3x minus 3x. I am happy to see those all cancel out. To be expected, I have a negative 2x plus 1 and a plus 3. So that is 4 minus 2, basically. 4 minus 2 gives me a 2. So my answer is 5 squared, which we can simplify to be 25. Okay. Thank you very much for tuning in. That is our multiplication and division type. All right. Very important that you understand how to identify these types so that you know where to start. Once you know where to start, you just apply the same method. Notice how I just constantly apply the same method and work through it slowly as not to make any errors. And that's it. That is our multiplication division type. Thanks.